In example 6, we consider the bacteria population that doubles every hour. Suppose that another population of bacteria triples every hour and starts with 400 bacteria. Find an expression for the number n of bacteria after t hours and use it to estimate the rate of growth of the bacteria population after 2.5 hours. So going back to example number 6, okay, we talked about bacterial growth. And the function that was used for the bacterial growth can be the following, where n is equal to the initial population times the base of e to the power of kt. Okay, and so that is our function. So we can actually write this function in terms of time, or as a function of time. So this is actually n of t, which is equal to the initial population times the base of e to the power of kt. Okay, and so what else do we know? We know that the given information tells us that the initial population starts with 400 bacteria. So we know it starts with 400 bacteria. Okay, and then it also then triples every hour. So we also know that 1 hour to triple. Okay, so we know that it takes 1 hour for the bacteria to triple. Okay, so in part 2, what we're going to do is we know that we have n, which is equal to the initial times e to the kt. So if it takes 1 hour to triple, that means that in our problem, n is going to equal 400 times 3, which is equal to 1200. So therefore, if it's going to triple, then we know that n is going to equal 1200. We know that the initial population is 400. We know that's e to the power of k, and we know it's 1 hour to triple, so t is equal to 1. So if we divide both sides by 400, we're going to get 3, which is equal to e to the power of k. And then we're going to take the natural log of both sides. So we have the natural log of 3, which is equal to the natural log of e to the k. So therefore, the natural log of 3 is going to equal k. So we found out what k represents in our problem. So now, in step 3, okay, we know that our formula, or the function n of t, is going to equal the initial, which is 400, times the base of e, and we know that the value of k is the natural log of 3t. Okay, so let's focus on this e to the natural log of 3. This is just something from before. If this is e to the natural log of 3, that's actually equal to 3. So we can now simplify this function a little further to be n of t, which is equal to 400 times 3 to the t power. And so now what we want to do is we want to find the derivative of this function. So if we want to find the derivative of this function, it's going to equal 400 times 3t times the derivative of 3 to t, which is the natural log of 3. So therefore, there's our function. And now what we want to do is, it says, find the expression for n of the bacteria after t hours, which is the following here. and we're going to use it to estimate the rate of growth of the bacteria population after 2.5 hours. So therefore, now we want to find n prime of 2.5. So that's going to equal 400 times 3 to the power of 2.5 times the natural log of 3. And using our calculator, we get an approximate of 6,850 bacteria per hour.